Hello everyone, this is Hugo and welcome to Hugo's Desk. A really short video just to introduce what this video is about. So first of all, thank you so much for coming to my anniversary stream. It was great to celebrate the 6 years of Hugo's Desk a couple of days ago. Now, one of the problems of the stream was obviously because I was celebrating, there was a lot of moments where I was talking with the chat and I was integrating with the chat and I was basically like answering Q&As, and also we had the giveaways as well. And obviously it's a bit hard to follow the tutorials. That's why I decided to do this version. This is an edited version. I removed all the Q&As, I removed all the giveaways, I removed the cake, I removed everything, and it's just the Nuke Compositing if you want to follow along. Goes without saying, if you still want to watch the full stream, you can go to this link and you can watch the whole thing. It has a lot of Q&As and a lot of really nice questions, and it's a really nice stream. Can't thank you enough for all the support, of course. Now, this video is all about like basically trying to teach you Nuke from scratch. It's called Nuke4Dummies and it's part 1. Part 2 and potentially even a part 3 will come soon, since I'm going to record next week again, part 2 of the anniversary stream, since we never finished. It goes without saying, of course, that this is just scratching the surface. Nuke is a really complicated software, and compositing in general is quite complicated. It takes a long time to master. So this is just give you a taster, just to show you a bit what the application can do, and also to give you a bit of an introduction to the interface and how things operate. Keep in mind that this was recorded live, so obviously there are certain things that could have been better and certain things could have been explained better, but I was doing my best to do it live. If you want a more bespoke training, like a pre-recorded training, I also have my Nuke course, which is available right now, and you can watch this video if you want to know more about it. And if you are interested to sign up, just contact me on social media or contact me on Twitter at Hugo C. Guerra. I would like to finish off by thanking BenQ for supporting this stream and making it possible for actually to happen. Again, goes without saying that I would like to thank my Patreons, my Twitch subscribers, and my members on YouTube for all the amazing support they give me every month. Your names are on the credits at the end of the video, of course. Without further ado, I hope you enjoyed Nuke4Dummies Part 1. I'll see you next time. So I'm going to go ahead and open Nuke and just get this show started. So let's begin this tutorial. As I explained before, keep in mind that this is just an introduction and I'm gonna plow through this, okay? So it's really going to be just an introduction. We're probably not gonna be able to cover a lot, you know. I am going to be doing a lot of jumps between things because I feel like there's some stuff that is important for you to know right now. Some stuff is not as important, you know. As you know, Nuke is probably the industry standard for compositing. It's the most used compositor in the world. Let's start with just the practicals of the interface, but I just want to give you kind of a bit of a rundown of the most important things to keep in mind that Nuke is really different from other applications. Now, obviously the version that you're watching now is the version that I have adapted and changed, so the interface is a bit different from the interface that you normally see. So I'm going to start with that. I'm going to start by putting like the compositing interface, which is this one. This is the typical compositing interface that you would get if you first load up Nuke for the first time. You know, normally you have, you know, you have like a viewer on the top here, and then you have a node graph on the bottom, and then you have properties bins on your side. Now, one of the things that I wanted to really kind of like talk about here is that Nuke is much more simple than people think, but it takes a long time to master. I think that's the main thing that you need to kind of keep in mind, that it is like, you know, it is like a bit of a pain to understand and master, but once you master it, it's much more powerful than After Effects, much more powerful than Fusion, because it has so many capabilities. And I'm going to do a really quick rundown of the actual OS, of the actual interface. So, as I said, we have the viewer here. Now, The viewer is where everything is viewed at the moment if you want to watch some footage. The node graph is where we have what we call a node graph, which usually is where we have nodes. And this is one of the biggest sticking points for people is the node graph thing, the tree, as people say it. And by the way, you press spacebar to go from full screen to not full screen on any of these places inside of Nuke. You can go full screen on the properties by hitting the spacebar. You can go full screen on the viewer by hitting the spacebar. You can go full screen on the node graph by hitting the spacebar. Now, I've already brought in some footage, but we're going to start by bringing in some footage. Now, there are two ways of bringing in footage into Nuke. You can drag and drop from the viewer or the Explorer, or you can, oh, and that one is easy, you just drag and drop. But I'm going to do the more normal version, which is to actually load footage. And now, for you to load footage, you have all these icons on the side here, and this is where you find all your filters, plugins, and gizmos. To bring in some footage, remember that these tabs, all these icons are separated by classes. And so you see, if I leave the mouse, it says image. If I leave the mouse on this one, it says draw. You know, it always gives you the information of what each of these classes are. So if you leave the mouse here, you see channel. If you leave the mouse here, filter. It's a bit stupid that the actual key is on top of the name. So you have transform. Everything in Nuke is like that. You know, if I leave the mouse here, it tells me what that is. If you leave the mouse here, it tells me what that is. If I leave the mouse here, it tells me what that is as well. So this is one of the coolest things about Nuke, actually. Every single thing is possible for you to view what it does by just leaving the mouse over it. And this is really remarkable because sometimes you don't know what something is, so you just leave the mouse and then it tells you. It's magical. Anyway, I'm going to go into image, and then we have two things here. We have something called the read and the write. So the read is the R button for read, and the read and the write to read in some images. I'm going to press the read button. As soon as I press the read button, it opens up a browser. Now, this is a browser which might confuse some people because it's very different from other applications, because you basically click once to go to things. So, and also it gives you the actual path, the actual computer path, because obviously Nuke is driven by, it was created first in Unix and Linux, so it's obviously it's going to be like a scripting kind of thing. I'm going to now bring in some footage. Now, let's start by bringing any footage whatsoever. Like, I have a bunch of projects. These, by the way, these are all kind of the projects that I'm kind of using for my course. So a lot of them will be like production stuff because I am using production assets for the Nuke course that I'm selling on Kickstarter, on Patreon. So most of these things are going to be like production, sometimes from the mill, sometimes from 5.smoke. It really kind of depends on what the production is. So I'm going to open up something from the mill, for example. So this is some footage from the BBC God Only Knows, and I'm just going to bring whatever plate. I'm going to just bring this one here. So as you saw, what happened there is that when you go into a folder inside of Nuke, you see what happens. You basically just go to the path, you go to the path, and then, for example, you go to a shot, and then in here, you see that right now, what you see is this, which is a bit weird, I know, because it has the name of the file, which of course it's the naming convention we had at the mill, but this actually has hashtag, 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 hashtag. These are the numbers of the frames, and then it says that this sequence is actually from frame 1001 to 1058, and then it says how much. Now, this is because Nuke groups the footage. So if you go to the Finder, you'll see all the frames, but in here, you will see them like grouped. And that's because of this little button here called Sequences. So if I untick this button, then you can see the individual frames. But we always work with sequences, and that's why this kind of works like that. Let's go back to this. I'm going to bring in this piece of footage. Now, and then you just press open. Now, if you want to open several of them, you could press the next button here and then go back into another file and then press open, and then it will open too. Now, so this happens, you get these kind of weird squares. These are what we called read nodes, and they have a thumbnail, and these actually give you a lot of information. They give you the information of what they do, like basically it has the name and it has the information of the file itself. So this file, for example, only has a red, the green, and a blue channel. There's no alpha channel on these ones. Obviously, if you open up something with an alpha channel, it would have a little, I didn't open anything with an alpha channel, but it would have had like a little white box there. And these are the nodes, and for you to watch them on the viewer, because as you can see the viewer is black at the moment, you just need to press on any of them, you know, just select one of them, and usually there's always a viewer here. So there's two ways. You can either connect to the viewer, or you can just press 1 and then it connects to the viewer. You can press 1 to that one or press 1 to that one, and then it automatically connects. So if you press 1, it automatically goes into the screen, gives you a lot of information, gives you the resolution. So if I press this here, I press F to center, by the way. So this is like 2048 by 1536. This was shot with an Alexa camera, full frame, like 5 years ago. So obviously that's why it's not 4K. So this is like a plate that we had. This is like a raw plate that we got from the Alexa. And on the viewer, of course, you can kind of see that for some reason, like magically, the viewer is actually already with a frame range, and this is where the confusion lies in Nuke. You know, the frame range of Nuke is always has to do with the first file that you brought into Nuke, okay? So the first file you brought into Nuke, that is going to set the timeline, the frame range of what you're trying to composite. Once, as I was saying, this view here, you can kind of see that it's set now to 1001 to 1058. And if I press double press on the file, you can kind of see that there's like some settings on the side here. These are the settings of each of these read nodes. So for example, if I press on this one, I see it. If I press on that one, I see that one. So this is everything I've opened so far. These are the settings of all these nodes. And this is what we call a read node. It gives you a lot of information. It has the resolution, it has the frame range, it has all these things. And as you can see, that file, which was the first one that I brought in, has 1001, starts at 1001, and then it finishes at 1058. Once this is very basic, if you want, you can press play, and then you can watch the video. Now, in Nuke, not like After Effects, if you press play, it doesn't play back in real time right away. It takes once to play it in real time. So it first has to cache it into RAM, and then it starts playing back. So as you can see now, it's looping. It always loops by default, and it loops by default because that's how we usually do compositing. We always loop the shot and watch it and watch it and watch it like some crazy people. So if you want, one thing you must notice, one thing you must know is that once it's RAM and it's playing back in real time like it is now, you need to be careful because as soon as I change anything on the viewer, it starts playing again. So it starts caching again on RAM. So if I, for example, open up, you see, now that it's bigger, it has to cache again. So that's one of the tricky things if you start previewing. And if I zoom in, it's already cached, but if I zoom out, it's already cached. And if I go in here, you see, it kind of is cached because now it's cached it in a really high resolution. So it's already cached in that way. But if you want to avoid this, to always cache when you zoom in and you zoom out or you do any changes, there is a little button on the top here. This button, which if I leave the mouse over it, see if I think it's cropped just a second. I pressed the wrong button, so I want to zoom in here. So if I leave the mouse here, this is what we called the full frame processing. So this means if I press this little button and I have this little red icon here, now it doesn't matter what I do, regardless if I zoom in, if I zoom out. You know, for example, if I decide to cache this file here, you see it's going to cache it once at this resolution. So you see, because it's much smaller than Full HD, and once it caches, it starts playing in real time. But notice that now I zoom in and it doesn't cache again. So be aware that that is the full, what we call the full frame processing. That means that it will always process the whole frame instead of just a section. And that is a really important thing because inside of Nuke, we're always like zooming in and watching a lot of things in detail. You know, this is the final comp, by the way, the shot that we did. So we always zoom in quite a lot. Like we always like basically do what we in the industry call pixel fucking, you know, and that's the whole idea of this. So we always want to zoom in. Anyway, let's keep going. The workspace that I'm running right now, someone is asking, I'm running the compositing workspace. That's the main compositing. That's the one that boots up with Nuke. I'm gonna change the workspace in a minute. So that's the idea. But this is the compositing workspace. There's a lot of different compositing workspaces. So as I was saying, you can play it back and remember that little button for the full processing. Now, When I'm viewing something, you can kind of see that my viewer is attached to viewer this footage, right? So let's say, for example, that we bring in more footage here. So let's say that we have, this is the cool thing about Nuke. Like, remember, when I press this piece of footage and press 1, I watch this clip, right? So now I'm watching this clip, which is Pharrell going through the chairs. If I press this clip, press 1, then I watch that one. If I press this one, now I watch that one. Now remember, notice how this one is not playing. The reason this one is not playing is because if I double click on it, you can kind of see that this one starts at 1071, not at 1001. And this is because my timeline is set to 1001 to 1058. Now, if I have a lot of footage inside of Nuke, if I temporarily want to bypass the timeline settings of 1001 to 1058, I can go in here, and where it says global, I can go into, you see there's like a lot of options here. We have global, which is setting for the settings of the project. We have input, we have in and out, and we have visible. I'm going to put input. If I put input, now as I change my inputs, the frame range changes as well. Notice on this one is 1001 to 1058. And then if I press on this one, it changes the frame range to 1071 to 1507. Now remember, this shot here, which is the home front trail that I directed, is going to take longer to process because this one is only HD and this one is actually 2.5K. So we're talking about like quite a lot more resolution to actually go through. This is the final comp, which I will leave caching. And obviously, the faster your RAM is, and the faster your disk is, and the faster your CPU is, the faster the previewing happens. But so as you can see now, this is full playing back, and once it's cached, I can then play it back forever. Now, remember, this caching goes through to your hard drive. So it goes through the memory and it goes to your hard drive. There's a specific place in Nuke that you can set up for the caching. And so once you open this shot again on another script, you know, imagine that you continue this shot tomorrow, or imagine that you go through this shot tomorrow or maybe in a few days, it will be already cached on your machine as a cache. So it is pretty cool in that sense because you can cache stuff to make it faster. We'll go through that as well in a second. But yeah, so keeping that in mind. Now, the cool thing about Nuke is the way that you can actually preview things in the same, like, so that you can compare things. I think that's why Nuke Compositing is so popular, because you can compare things. So, for example, in here, you can kind of see that we have the viewer, you know, this little line, we can set it up to that one, then you can watch this. Now, watch how the viewer has multiple inputs. It actually has 9 inputs, so I can press this one, and then I can go and have another one. So now I have 3 inputs on my viewer. The cool thing about this is that now that I have 1, 2, 3, if I click on the viewer, I can then press 1, 2, 3, and I can actually watch 3 things at the same time, which is really advantageous if you're like working with a client and you're just showing them something. So imagine if you're with a client and you're showing them, okay, guys, this is what we had and this is what we did, you know, so that then we can kind of like split in screen and go between them. And actually, in fact, we can even like do a split screen and a wipe between them. Obviously, the wipe is not going to work because obviously this one is HD and this was 2.5K. So it's not going to match the wipe. But that's normal that it doesn't match because it's different resolutions and it's different things. But that's also for you to keep in mind that that's kind of how it works, Nuke. You can kind of play back things in the background. Although, do keep in mind that I have a quite powerful machine. So you do need a quite powerful machine if you're going to really go for it. I highly recommend you using dual graphic cards because, and Nuke does support 2 graphic cards. Although you need to be careful with this, like, because you see, it says here, enable multi-GPU support. It actually is going to use both of them, but it only uses both if they're both the same. Okay, so they cannot be different graphic cards. They have to be exactly the same manufacturer, exactly the same VRAM, exactly the same settings. Everything has to be the same thing. Okay. Anyway, I'm getting ahead of myself here. Okay, so Sachin Patra VFX asks, what is color management inside of Nuke? So color management is something that allows you to read in footage into Nuke on a specific color space and read out with another color space. I'll show you really quickly what I mean with what I just said. So if you look closely, this piece of footage, which is a DPX, which is a type of file format not used very much anymore, This type of color usually has the capability of storing more information than just the regular values of an image. So this actually is a high dynamic range image. So for example, look at this part of the staircase here. It looks overexposed, right? But it actually is not overexposed. If I drop the exposure slider on the viewer, which we haven't talked about in a second, but if I bring this slider down, you can kind of see that there's still a lot of information there that looked like it was overexposed. The same goes for this light here. This lamp also looks like it's overexposed, but it's actually not. There's like a lot of information here. And this is because these cameras have a lot of dynamic range. Now, having said that, each camera has its own color space, and that's what color management deals with. So for example, this one was filmed with the Alexa color space, and it was converted to DPX, Cineon color space, which is this one here. So these are all the color spaces that we usually have inside of Nuke. And as you can see, we have like the typical color space, which is Cineon, which is the DPX type of color space. Then we have linear, sRGB, Rec 09, and these are basically, some of them are the color spaces of the input of the file, like so maybe it would be the color space of the red camera, or maybe it would be the color space of the Alexa camera, because every camera has an high dynamic range sensor, right? So there's a lot of things that it captures. Obviously, I'm really oversimplifying this, okay, but it captures a lot of data. Like we're talking about like thousands of values of luminance. But for you to watch it on your monitor, it has to be brought down to a level that it doesn't blind you, okay? So the image has to be lowered. It has to basically be converted with what we call the LUT, so that it's actually possible for you to view it. And these are what these LUTs are. We have the Alexa LUT, we have the P-Log LUT, the red LUT, the sRGB, the Rec 09. All these are the different LUTs and different color spaces that exist for each camera in each file format. Now, color management, what it does is it manages all these color spaces and converts it to one single color space so that you can view your image inside of Nuke. Because if you didn't do that, everything would not match, you know. So in Nuke, everything is linear. And you can kind of see that here when you look at the color curves here, for example. So everything in Nuke is linear, which means if you look at this curve, you can kind of see that what is 0 is 0 and what is 1 is 1. But if you go to the curves of sRGB, Rec 09, Cineon, they all have different curves. That's how they bend light and darkness to be viewed on a specific monitor. So that's what color management does. Color management is a methodology to basically help you to manage an incoming file to be converted to linear, and then when it goes out of Nuke, it gets converted to the color that you want for delivery. An example of this would be you bring in something from an Alexa camera, the color management system converts it to linear. Inside of Nuke, you work in linear, and then when you output from Nuke, when you render, you need to convert it, for example, to Rec 09 for TV, or you convert it to sRGB for web, or you can convert it to linear to give it to another application, or you can convert it to a Rec 2020 for HDR broadcast. So there's a lot of those things going on, and that's what color management does. It manages all these color spaces. Obviously, the most modern color management tool right now is ACEs, which is a method that the Academy, the Oscars Academy, is trying to give a standardization of color management. I hope I've explained you a little bit what color management is. This is the shortest version that I can find, really, and I hope it works. Really quickly, just go through the viewer really quickly. So I have one image here. Remember that we can have up to 3 connected to the viewer, and at the moment I have this one here. If I press spacebar to make it full screen, then I press the F button to make it full screen here. A couple of things to think about that are more important on the viewer itself. On the top here, we have the non-destructive f-stop. So this is basically the f-stop that you can basically go up on the f-stop and you can go down on the f-stop. This is incredibly important. It's incredibly important because this is the way you're going to check for grain. This is the way you're going to check for edges. This is the way you're going to check if there is like still information on something. So for example, like I showed you on the staircase here, we can kind of still see the information there. That's really an important slider, which is the f-stop. It's what we call the exposure slider, okay? So we have obviously the gain, which goes down or it goes up, and this is non-destructive. As soon as you touch it, it becomes red. That's because it tells you that it's been changed. So you can press the red button again and then it goes back to default. Default on the settings of Nuke is F8. That's the default for exposure. You can also do the numbers here, which are equal to the multiplication of the image. So if I go with 2, that's a multiplication by 2. 3 multiplication, 4 multiplication, 5 multiplication, 6 multiplication. I can multiply the image just like a multiply. On this side, though, I have the Y, which is the gamma. Now, the gamma does not deal with exposure. It doesn't deal with brights or darks. It deals with the midtones. And so when I slide it, notice how nothing gets overexposed, as opposed to the exposure, which when I expose it, becomes overexposed. It becomes brighter. When I go to gamma, nothing gets overexposed. What you do is the midtones or the skin tones become brighter, but not the brights and not the darks. The same goes if I go downwards, nothing gets, the overexposure is still there. You see, it's fully overexposed. Now, the gamma is incredibly good for you to see skin tones. So, for example, here I noticed that there's like a yellowish tint to the staircase. So, which is really good information. And in here, you can kind of see that we have 2 different greens. Although in here, you can also see that the blue is much lower in terms of luminosity as well. So this is a great way for you to see the color density of things. So for example, in here, if I go all the way down, you can kind of see this shirt did look like it was white, right? But it's actually not white. If I go really down on the gamma, you can kind of actually see that the shirt is actually yellowish. This is going to be very important when you're matching things and when you're merging CG with footage and doing all those kind of things. And so again, as soon as you touch anything, it becomes red, and then you can press on it and do it. Now, like I said, I'm only going to talk about the most important things. I think these are the most important things by far inside the viewer, the exposure and also like the gamma slider for the color in the midtones of Nuke. Down here, of course, we have the timeline. We can scrub through the timeline, of course, obviously. This is really simple. I can go frame by frame by using the arrow keys as well. You know, I can, of course, go back. I can go to the last frame. I can go to the first frame. I can go each keyframe. I can go frame by frame as well. I can press play. I can play backwards as well. And then, of course, I have repeat, bounce, stop, continue. So bounce, of course, it goes bounce, repeat, stop. It's really straightforward. You can also go every 10 frames if you need to. So, for example, if you are doing some rotoscoping, you have 10 here. You can go every 10 frames if you want to, or you can change that value by changing it there as well. That's also very important. Frames per second is the frame rate of your viewer, but remember this is linked with the settings of your project, which we're going to go through in a second. And currently it's set to input, not global. So I think those are the most important things. There's, of course, obviously more here. We can zoom in, zoom out using the wheel, or, of course, using the Wacom tablet, which is how I normally comp. I usually use a Wacom tablet because it's just much easier to just use a Wacom tablet for compositing. So, and you can kind of like zoom in and zoom out. Obviously, I'm not going to go through the settings on my Wacom tablet. But if you want, if you know, if I press the option or the alt key, I can kind of like drag the viewer, zoom in, and do things to it. But you can also right click. If you press the right click on the image with the alt, and then you can kind of like go sideways. But shortcuts are not the important thing. You can kind of check those things later on. We also have like safe zones if you want, and guides. We also have exposure meters to tell you what's overexposed. If I switch this exposure meter, for example, here, it shows you that this section is overexposed. This behaves a bit like a zebra on a camera. You know, it tells you what's overexposed on the image. But let's continue, and as I go through things, I will probably go through other stuff that we are not covering right now. So that's the viewer. Now let's talk about the node graph. And the node graph really, I know that you can't see because I'm on front of it, but I'm going to switch here. But you see, we also have like a little map here that allows you to kind of like go through, and you can even make it bigger. You can kind of like navigate through all the nodes. Obviously, this script is quite small, so it doesn't really matter because you can kind of navigate here. But you also can like zoom in, and you can right click with the Alt and kind of like drag and go sideways on the node graph. And one thing that you should know is that the way that you bring in nodes into Nuke is very special. So you can actually, you know, there's a couple of ways of bringing something. So let's imagine that I have this image and I want to make it brighter. Not brighter on the viewer because that's just like a non-destructive method of making it brighter, but I actually want to make it brighter for real, you know. So if I want to do that, there's a couple of ways. I can go in here to my color correction tab, and I have a bunch of color corrector tools. These are like plugins and tools that I have inside of Nuke. They're all coming with Nuke. And for example, if you want, you notice that like the most important nodes in Nuke have like a little shortcut next to them. So for example, grade has G, color correction has C. Like the most important nodes usually have, you know, roto is O, roto paint is P, you know, read is R. If you go to blur is a B, so if you go to transform, it's a T. So there's a lot of like shortcuts related to a specific shortcut on the keyboard. So for example, if I want to do grade, I can press the G button. So if I'm on the node graph, if I've last clicked on the node graph and I press the G button, a grade node appears. And this is a grade node to do color correction. Now, keep in mind that shortcuts in Nuke behave differently from where you've last clicked. So if I've last clicked on the viewer, if I press the G button, it actually changes to the viewer to only showing the green channel. So for example, R is the red channel, green is the green channel, the G button, and then B is the blue channel. So you can kind of see the different channels. And this is really important because when you're doing compositing, you want to watch the red channel and the green channel, which are the majority of the time where the luminosity exists, but then the green and the blue, the green for the keying and then the blue usually is the most noisy channel, and that's where you actually see all the noise that the plate might have. Watching it on the blue channel, it tends to be, you know, where you see the noise pattern. So keep that in mind, that when you last press on something, that's where that shortcut becomes available. So I'm going to press R again to go to color, and again here, for example, if I press G, it does a grade node. If I press B instead of the blue channel, it makes a blur. Now, once I have a node, there is this way that, as I showed you, I can go in here, you know, so there's three ways of doing nodes. I can go in here and actually go into color correction, and I can go and do grade. That's grade, a node. The other way of doing a grade node is to actually press the G button. That's also a grade node. And there's another way, a third way, which is if I hit the tab button, I can write something down. So I can do grade, and then you can kind of see these are all the nodes that start with grade. And then if I press enter, it makes a grade. And if I hit the tab button again, you notice that the last thing that I did was a grade. So that's the one that is still there, and I can press the button. And as you can see, there's like a star system. There's actually like a shortcut system. If you want, you can highlight some nodes that you use the most. There's a lot of things that do that, you know, in that sense. So now, the way it works as well is that they always get disconnected by stuff if you just open them without clicking on something. But if I've last clicked on the read node and I press the G button, the grade node gets attached to the node, okay? So obviously you can still attach it. And this is the cool thing about node compositing. We're going to go through this in a second, but you see, node compositing is all about having options and having two things. So you see, for example, here I have now two grade nodes. And so what can I do with this? So let's look at grade number 1, and then let's going to select this grade node here. Grade number 5 is on here on my viewer. And then I have grade number 1, press 2, and now I have 2 grades. So now if I go to my viewer and I press 1 and 2, I can swap. And you can kind of see that Nuke has highlights of what you're watching. So if I press 1, I'm watching this grade node. If I press 2, I'm watching that grade node. So this is the way that you actually do options when you're doing some kind of compositing. So for example, if I now go into, I double click and I open grade 5, this is the latest grade node that I'm changing. So for example, now, let's go to grade 5. And as you can see here, let's say that, for example, I want Pharrell to be brighter. So I can go into the multiply and drag, and now I have an image that is brighter. Now, if I'm not happy with that, if I go now to my grade 2, and I press grade 2, because you see, if I press double click on grade 5 is now on the top of my settings properties. If I double click on grade 1, now grade 1 is there. So let's say grade 1, I'm actually going to lower the exposure instead. So now I have grade 5, which has a more brighter version, and I have grade 1, which has a darker version. If I now go between them, I can now see both versions at the same time, including I can play them back and watch them playing back at the same time as well. And this is where node compositing becomes so powerful, because you can then have all these trees with different methodologies and different versions, and then actually talk with your client and show your client, do you like this version? Do you like that version? There's like this kind of momentum going into compositing where you actually have a node tree. And I know for some people here that don't know Nuke, it's always a bit tricky to get your head around the node compositing factor, but keep in mind that we'll get this done, don't worry. Now, I'm going to open another script because I want to show you really how powerful this becomes with node versus layers. I'm going to open up the new script. By the way, keep in mind that what I have open here, this is not part of Nuke, okay? This is actually part of the interface. This is actually my pipeline. I have my own pipeline where basically, I have my own tools, I have my own plugins, so don't expect to see this menu inside of Nuke because it is like a different thing that I've built on top, because Nuke is Python based, so you can build stuff on top quite easily. So anyway, I have something else here which I'm gonna comp real quick just to show you how Nuke operates. So this is like from a short film I did years ago. Here's something that is very practical, and I guess here to show you what an alpha channel is. So this is a piece of CG. I'm going to set my viewer to input. And so this is a piece of CG, which is of a monster going up. It was done in CG by my lovely students at Campus I-12 in Sweden. This is 5 years old. This was rendered in V-Ray. And as you can see, this is like a monster that we have here in CG. This is a render. This is an EXR inside of Nuke. And at the moment, this is what we call the multipass. This is not a multipass EXR, just a single EXR. But someone was asking about what an alpha channel is. And I guess the thing that you'll see when you look at this image is that this read node here, which is this one, this render here, you can kind of see that it has another little thing here, which is a white box. That is telling you that it has an alpha channel. So that would be red, green, blue, and alpha. And so that's why it has an alpha channel. Now, an alpha channel is what will tell you in Nuke what a transparency is. So if I press the A button on the viewer, and notice how it changes here on the top. You see here, it says RGB, right? I'm going to just like bring the monster here to the face. So you can kind of see that this is RGB, and then we have red channel, and then we have, you notice how we have the RGB for red, green, blue, alpha, luminance, and matte overlay. So if I press A, I see the alpha channel, and it's the same thing if I go with the red channel, with the R button, the green channel with the green button, the blue channel with the blue button, A for alpha channel. Now, this here is an alpha channel. An alpha channel is basically telling Nuke, someone was asking on the chat, so an alpha channel is telling Nuke, or other applications, doesn't need to be Nuke, it could be like Shake, it could be like Fusion, it could be any After Effects. It tells Nuke where it's transparent and where it's not transparent. So where it's white, it's fully opaque. Where it's black, it's fully transparent. And so this is a file that gives Nuke that information of what is transparent. So why is this important? Well, this is important because if I want to merge something on the background, then I need some kind of transparency. So let me show you what I mean. I'm going to just bring in a color. So I'm going to go into my read node, and I'm going to go to the constant tab. The constant, by the way, is just a way of making a color in Nuke. It's like a solid. It's like solid that you would have as well. So if I Yeah. Someone is asking about the green cache. That's because it's cached locally onto my solid state as well. So as I said, the constant is just like a solid, and as you can see now, it's black. And the reason for the solid to be in HD, that's because the project settings of this shot is in HD, and we're gonna go through that in a second. I'm just gonna like swap the resolution to the same resolution as my video, just so that I can do that. But I'll explain those things in a second. So now I have a constant of black, and if I go in here, you can kind of see I can make it white, and I can make it gray, or I can make it colored. I'm only gonna make it white. So let's do it gray. So 0.5, which is not gray, by the way, Nuke, because it's linear. So I'll just do like a random value of gray. So this is gray, which is the background, and this is my footage. They both have the same resolution. Now, the entire concept of Nuke, the entire concept around Nuke, is something that we call A over B. Okay, so this is done with the merge node. The merge node can be found on the menu of merging, where we have all the ways of merging something. And on this situation, I'm going to press the M button for a merge. You can also type the tab button and do merge. And this is how you do a merge node. Merge nodes are basically A over B. Something that goes on the background, something goes to the foreground. And so at this stage, what I'm going to do, I'm going to just reverse these two. The concept of compositing in Nuke really goes down, and it's basically this, merging two things. Because there's no layering system, so we have a merge. So in this situation, the B is for background. So I'm going to press B into the constant A to the foreground in Nuke, and that will be the result of this merge. So now if I press 1, you can kind of see that now the monster is comped on gray. And why is it comped on gray? It's comped on gray because of the alpha channel, you see. Because, like I said, the alpha channel, whatever is white on the alpha channel is producing opacity, full opacity. Whatever is black is producing full transparency. And obviously in between, when you see gray values, that is semi-transparency, because obviously that is the motion blur that we baked into the scene. And so now you can kind of see that now this is comped together on grayscale, on the gray background. So that would be how I would merge this, okay? So I know we're going really basic, but that's the whole point, right? Okay, anyway, let's also start by setting up my like a project. So we're gonna comp this. We're gonna comp this plate, which is one of my students, by the way. We're gonna comp this plate of one of my students, pretty scared of this monster. So we're gonna comp the monster into this shot. These are all my students from Campus I-12. They did a lovely job with makeup, as you can see. And we did like a concept short film. It wasn't really a short film, it was more like a concept. And yeah, so someone was asking if this is ProRes 4444. No, this is ProRes 444 because there's no alpha channel when you film, of course. Cameras don't get alpha channels, unfortunately, right? First things first, I'm going to save this as a project. So I'm going to do this. I'm going to go, because I want to save it, and I'm going to go through the saving process and also getting the project settings scaled up. So I'm going to do File, and I'm going to Save As. So this is obviously has been saved already, but I'm going to save it somewhere else. I'm going to save it just on my desktop because we're just doing this for the sake of it. We're not doing this for real and for any production. I'm going to do a new folder and this is going to be, the folder is going to be called Stream, and I'm going to press OK. So now when you save something inside of Nuke, you basically want to consider naming it in a specific way. So I'm going to name this, let's say monster comp, like monster underscore comp. I'm always going to put an underscore. Reason I put an underscore on the name of the file, because I want to make sure I don't screw any scripting or any problems with Python scripting. So I'm going to do that. And then I'm going to put this V001, and that is going to be then .nk, which is Nuke. So this is going to be, misspelled monster. So monster underscore comp V1. The reason I put V1 here is because there's an automated way of Nuke saving versions. So I'm going to just press save. And now if I press, you can't see it here, but you see if I don't run Nuke in full screen, you can kind of see it says here monster comp V1. So that's the name of the script. on NukeX. I'm running NukeX at the moment, but you don't need to run NukeX, of course. So the way this is going to work now is I'm going to now that I've saved it, notice how if I go in here, I can of course do save with, of course, Control S. But if I want, I can do save new version. If I press save new version, because you have here save comp as, save new version. If I press save new version, notice how now the script is called v2. So that's why I put v002, because I want Nuke to automatically name my script. And if I go to my desktop here, you see now these are the two scripts I saved. So that's why I do the V, because then I can automatically just keep doing versions. And I would really recommend you to do a lot of versions inside of Nuke, because Nuke is really crashy. It crashes all the time. It's really unstable. Sometimes you lose work. So I would recommend you to actually really version up. And now, one cool thing about Nuke is that the actual file is nothing more than a text file. I'll show you this. So if I drag this into a text editor, you'll see that this is actually what the script is. You see, this is the actual script, and you can actually see the stuff here. You see, this is the actual root, and then we have a backdrop, then we have a read node, then we have a grade node. Remember, we even have the values of the grade node. We have a read node, another reformat, another grade node. These are all the nodes that exist in Nuke. And the cool thing about this is that you can copy-paste text in between. So if I would have now copy-pasted this, imagine that I copy-paste just this section here, for example. So I copy-paste this read node. Like, let's copy-paste this grade node. So if I copy-paste this grade node here, and I copy, and I go to Nuke here, I can now actually paste it into Nuke. So you can copy paste text into Nuke. So you can message people scripts, you can actually read scripts, you can actually copy paste it, put it on an email, you can send it on a messenger. The only thing you need to be careful is that it has to be not on rich text. It has to be without rich text. It has to be simple text, okay? So keep that in mind. Anyway, now that we've saved, I'm only gonna keep the stuff that I need. So I'm gonna delete this stuff here because I don't use it. So I only have the CG here. And now the next thing I'm gonna do is and this is really important, okay? Don't forget to do this, okay? So when you have a shot like this, you need to consider what your output will be, okay? So obviously this was filmed in 4K. This was filmed in 4K because this was filmed with the Blackmagic camera, okay? So it was filmed with a Blackmagic camera in 4K with full sensor. Normally when you do visual effects, you do that. You usually like render out, like you film with more resolution than you need, because you might need to scale, you might need to track, because remember, every time you have some kind of problem with stabilization, or if you need to scale up, or if you need to blow up a scene, you'll lose resolution, right? So you film with the best resolution possible, and then you select your output. Now, we did the same thing with CG. This CG was rendered in 2.5K. The reason why it's rendered in 2.5K is because we were going to deliver it in 2.5K. We normally render the CG at the delivery format. Sometimes we render with a few more pixels, just to compensate, for example, if you have lens distortion that you need to apply to it. So in a way, like sometimes we do something that we call an overscan. An overscan would allow you to basically have enough resolution on the sides of the image so that you can apply the lens distortion and still have enough resolution to take it over. I'm sure I'm confusing people quite a lot, but I'm just like trying to explain as we go, and I understand that this becomes a bit complicated, but you guys can always watch this video again, and obviously I have more videos on my YouTube channel as well, and obviously you can sign up to my course as well. My course goes through all these things. One thing that you need to consider is the settings of your project, okay? That's really important. First thing you need to do is to do settings, Most important thing is the project settings on Nuke, on the project. So project settings can be found on either if you go into Edit, Project Settings over there, project settings of this project, or you can press the S button. Once the S button opens, this is the project settings. So as you can see here, the name of the script, you can make some comments. You know, for example, done by Hugo. If you are sharing this script with other people, you can make comments here. And then we have here, which is, this is really important. This is really where the magic happens, okay? So we need to first of all sign up for a range of where we're gonna comp. And obviously the range depends on the CG, right? So the CG is 1001 to 1128. That's the range that I have. And so I'm going to do that. I'm gonna start at 1001 and I'm gonna end at 1028. I'm also going to lock my range. The reason why it's important for you to lock the range is because if you don't lock this, every time you bring something new from another plate, it will change the range. So imagine if you brought in a plate that was 2000 frames long, the frame range would change to 2000. So if you don't want that to happen, if you want to lock your frame range for delivering, then you need to lock it. Also, I know this was not 25, it was 24 frames per second. That's a fact. I know that was done like that. And then in here, I know I'm zoomed in too much. Sorry about that. So I need to like zoom in a bit less. But as you can see here, we also have resolutions. And this is, of course, all the resolutions we can have inside of Nuke. It can pick. There's a lot of presets, of course. But for simplicity's sake, I'm going to keep HD. Okay, let's say that we want to deliver an HD version of this render. You know, we want to deliver it in HD. We don't want to deliver in more than HD. So I'm going to set HD to the resolution of my comp. Now, here's where a lot of confusion comes from people trying to use Nuke for the first time. You're probably thinking, okay, I've set, because this is not After Effects, right? So you're probably thinking, okay, I've set my resolution, but why do I still see 4K on the plate? And that's a really conscious thing. Like, Nuke does have this, and the reason for this is because Nuke is resolution free. You know, it's like it's resolution independent. Okay, because it's resolution independent, it doesn't really care if you are using 4K, HD or nothing. You can bring in a 20K plate, you can bring in a 10K plate, because you're reading it from file. And as you can see here, the CG is still 2.5K. My plate is still 4K, although my settings are HD. Why is this important? Well, it's important if I do something else. Let's imagine that now I bring in a constant. Remember, I was doing a constant for the color. I'll bring in a constant, and let's say that we make a gray constant again. I'm going to press the 1 to attach to the constant. And you see, this constant is set to HD. So you're probably thinking, why is it set to HD? Well, it's set to HD because my project settings are set to HD. So everything that is created by Nuke itself, either being a roto shape, either being a constant, or a transform node, or a reformat node, or a rotoscope node, anything that you construct inside of Nuke will always be HD. A reformat node will be HD, the transform node will be set to HD, the roto will be set to HD. And this is really important because this is where Nuke is different from other applications. That's where you have a project setting, which is the setting of your delivery, but also this resolution is the setting of your comp. So anything you do to this comp, but either a rotoscope, a transform, or a constant, will have that resolution. So that's why you need to be careful, because if you don't really pay attention to the resolution that you're going to deliver, you need to be careful, because then everything else in Nuke will have different resolutions. Always remember the resolution is incredibly important, okay? Incredibly important for you to set up this composite. So let's pretend for a moment that I'm going to deliver HD. Now, there's other things here. We're not going to go through them today because we don't have time. There's also management. I'm not going to go through management because I'm currently using the default management. Obviously, there is ACEs as well. But please keep in mind that this render, which is from 2015, does not have ACEs because this was rendered in 2015. We didn't use ACEs back then. And also, this plate is actually rendered from DaVinci without ACEs either as well. So keep in mind that I'm not going to run ACEs today. Although you have seen tutorials of me on ACEs. I remember a few years back I did a stream on BenQ with ACEs, so maybe have a look at that, you know. And obviously, like Victor Paris is always doing a lot of things with ACEs, you know. You can kind of check some of these wonderful tutorials on Netflix as well, and there's a lot of information there. Now that we've established this, how do we make this work, right? Because remember, we're trying to comp something that's 2.5K and we're comping something to the 4K, but we're delivering HD, right? So, as a rule, when you're compositing something like this, you kind of want to consider, okay, I want to merge these two, right? Remember, I pressed the M button for the merge button. And so I want to merge the monster into the plate. And okay, so the plate is the background. That's fine. Remember, always B is for background, and A is for foreground, and then I'll put the monster. Now, obviously in Nuke, the way it works is that if you had another layer, then you would have merged something else, and something else, and something else. We'll probably get to that, but just so you guys know, like you know, that's the kind of thing that works. You know, you can kind of like merge and merge and merge. That's how you basically grow it as a tree. You know, you go through it as a tree. I should have really like made like a huge comp just to show you a tree, I guess, but I'll get to there. Here's the problem, the first problem. So you're probably thinking, okay, I've merged the 4K plate with the 2.5K plate of the monster. Let's view what we've done, okay? Let's watch our fabulous composite. Oh, the viewer is like, I don't usually work like this. And by the way, I'm gonna ask you for a favor. Like, I hate working like this. I hate to have such a small node graph, and I hate to have all the properties here. If you guys don't mind, I'm going to switch the workspace to my own workspace. Now, I'm not going to teach you how to change workspaces. That's really easy. You can find it on the web. You can find it on Foundry, but I'm going to switch to this. This is how I work. Doesn't mean that it's the best way. No, not at all. Like, that's how I prefer to work, okay? I like to have a very big node graph on this side, and I have to like to have a very big screen on this side. And then I like to have all my properties actually being individual menus. I like this because that allows me to have two of them side by side if I want to transfer data. So I prefer to have floating. You know, I really prefer to have floating. So once I'm here, remember we were discussing, okay, I have a 4K plate, I have a 2.5K monster, I'm going to merge it. And look at that. For some reason, the monster is not scary at all. Like, the monster actually looks ridiculous. Not only the monster looks ridiculous, but also, for some reason, it's also not working properly. Now, well, you see, I play back, nothing is working, and you're probably like thinking, oh my god, what the hell did I do? Well, first of all, you need to change this input to global. The reason for that is because you remember we set the settings to global. So we have a locked setting of 1001 to 11828. And so now, that now should work. But obviously, there's something wrong, right? Because the monster is really tiny. Now, the reason for the monster to be really tiny is because Nuke always carries the resolution from the background plate, okay? So whatever is attached to the B pipe would be the resolution of the incoming composite. And that's why when you look at the monster is not scary at all. It's like a little monster. And so, in fact, what happens here is that you actually need to adjust the size of either the monster needs to be bigger or the plate needs to be smaller. Because we're delivering HD, there is no point of us using the plate in 4K. No point at all. Except if you needed the 4K, you know, usually I can form plates in 4K when I'm kind of considering that maybe I need the extra resolution for keying, or maybe I need the extra resolution, you know, for tracking, or I need the extra resolution for maybe like some kind of stabilization that I'm trying to do. In this case, I'm not doing any of that. I mean, obviously there's some tracking markers to be removed here, but it's not like we need the 4K. So I'm going to start by reducing the resolution of this plate. Now, to reduce the resolution of this plate, I have a few ways. If I go to the Transform tab, the way that you want to do this is on something called the Reformat node. Now, remember what I said on the beginning. I'm jumping a lot in a lot of things. As you probably noticed, look at all these nodes. I really would recommend you to go through a course, because a lot of things will be really over, like, I will not talk about them because I can't do this. I mean, remember, my course is 70 hours long. As I was saying, the reformat. So I'm going to go in here, and you see, here's another thing to consider. When you put the reformat node, you see the reformat node automatically picks up the resolution of your settings because we've set it to Full HD. So you can either have it like this and then plug it into the pipe if you want to, or you can select the read node and type reformat. Now, consider that when you do this, when you type it to the reformat, it will always pick up the resolution of the incoming plate. So now that I have a reformat here, let's have a look at exactly what happens. So as you can see on the image here, this is not quite what we wanted, right? So as you can see here, we have HD, but for some reason we have this bounding box issue. And in fact, if I go in here and I click the black outside, look at this, like it's actually cropped, right? That's not gonna work. Well, the reason for this is happening is because the Blackmagic Cinema, the old Blackmagic camera, was actually not 16:9. It was, I don't know why, it was like some kind of weird whatever they were making. It was like 1920 by 1060 aspect ratios. Like, I guess like that's like 19 by 9.5. I have no idea what they were thinking. Anyway, so that's a problem, and that's because the reformat node has basically 3 types of reformatting. You can do reformatting where you actively choose the resolution. So, you know, that's actually now doing 720p, or you can do Full HD, or you can do 4K, or you can do 1K. You know, you can pick whatever resolution you prefer to deliver. Obviously, if you're picking up a larger resolution, you're going to crop the image and you're going to stretch the image. So you need to be careful with those things. And that's kind of why we're doing this, why we have a 4K plate, okay? We can choose the output, or we can just use HD. Now, that's one way of formatting. The other way is to box. And box, of course, we just tell them exactly what we want. So let's say I want specifically 400 by 200, you know, pixels, why not? You know, or I can do scale, and scale allows me to just scale down or scale up by the factor of 1. So for example, and notice how Nuke is really, I'm going to say first before I do this, Nuke is really indifferent in terms of resolution. So if I go all the way, look at this, I'm scaled by 10. So now this is a 40K image, okay? So this is now 40,000 pixels by 21,000 pixels. Obviously, when I play it back, it's really slow. It's really slow because now it's a 40K, which I guess it's what we're going to shoot when Blackmagic launches a camera next year, because they're already at 12K. So since they're already at 12K, I'm sure they're going to get 40K soon. Let's see what would happen if this was 12K. So I'm scaling actively. Obviously, now I'm just blowing up pixels. I'm just like basically scaling it to 20K, which is pointless, but it's so slow, by the way. So even with my double machine, dual GPU, it's still slow. So let's do 12K actually. Let's do 12K. And it is also slow, but it's probably not as slow, I guess. Yeah, it's not as slow. So it would be fine. But yeah, so notice how this is so big now that it doesn't even cache. Remember, it doesn't even cache at 12K. I think Nuke is struggling with this thing. So let's just go back to 1 here, and let's not have that. So this is the different ways you can scale. You can either format to a specific scale, you can do a box and put a specific format, or actually scale by hand to a specific res. This is really handy, especially when you're applying lens distortion, because then you can scale to a factor of whatever lens distortion you're trying to achieve, and so it's also very powerful in that sense. So for the purpose of this tutorial, I'm going to do format, and remember these problems are coming because the resize type is width, right? So if I now would put to height, it would zoom in. If I would put fit, it would fit into that frame of 16:9. If I would fill, it would zoom in as well. If I would distort, it would distort the image to actually be part of that resolution that he's trying to force the plate into. And of course, if I put none, this is where I get the actual 4K plate just zoomed in. So this is now 1:1 in 4K. So it's basically we're watching the 4K plate on a window of HD. So that's kind of like the way that it works here. So obviously what I want here is I'm gonna want to resize to basically to height. Obviously, the problem though is that, as you can see, it zoomed in on the sides, so there's a bit of an issue here with the tracking and the CG. Not that it will be a problem for this specific shot, but the issue here is because my resolution of my CG, you know, in here is 2.5K by 1382, which is the same aspect ratio as my, the same aspect ratio as my footage. So what you want to do is actually to use the formatting to match the CG, at least for now. That's what I would do on a plate like this. Remember, of course, this has huge implications. Once you reformat something, you're going to lose that extra information on the bottom, but when you merge the CG, basically what you want to do is you want to do everything in 4K. So that means stabilization would be done here, tracking would be done here, keying would be done here, everything at 4K, and then only when you're ready to merge it with the CG, that's when you reformat. Only then do you reformat the plate. If in fact the plate is the same, like bigger than the CG, only if that's the case. I don't want to confuse you here too much, but it's like really difficult to render in 4K, so it would be very unlikely that someone would render this in 4K. It's really painful. So most of the times we render in 3K or we render in 3.5K. We a lot of times render below 4K, and then don't tell anyone, it's a secret. Please don't tell Netflix. I've never done a show to Netflix, but I mean Netflix forces people to do 4K in everything. But obviously, I know that a lot of companies don't do 4K because they can't do it. It's just too much. It's too much rendering. It's too much power to be just wasted on render time like that. So it's very common for you to basically render on a lower resolution. So obviously, I'm not going to deliver 4K. I'm going to deliver HD. So none of this matters. Even I could have even delivered this resolution if I wanted to. So what I'm going to do here to match this up is I'm going to choose the same resolution. So if I open up this here, this is now 2560 by 1382. I'm now going to pick that resolution. So if I go all the way down here, it is here because Nuke has all these these templates. These are the resolutions that are templated inside of Nuke. But below here, the ones that have no label, those are the ones of just stuff that you imported into Nuke. So whenever you import something, it will show up here. So keep that in mind. So I'm going to pick the same one, which is 2560 by 1382. And now my footage is now correctly converted to the same resolution as the monster. And if I now merge both, you can kind of see that the monster is now on the correct place. Obviously, this is just A over B. The beginning of the shot, monster is not even there, so I'm gonna do an in and out here, so we don't waste so much time watching this. I'm gonna press the I button to make an in point here, and then we're just gonna preview just the comp itself. Going back to the shot, so now this is the comp we have, right? So this is what we call a pre-comp. This is what we call an A over B. So now we have the monster there, and we have the merge version here, and everything works. The resolution is now correct. Now, for the moment, I'm not going to actually put HD here, and actually temporarily, I'm actually going to, just to make everything more simple, before I deliver, I'm actually going to change my settings, the project settings, to the resolution of my CG, because I want to make sure my rescales and my reformats and my rotos and my transforms all match to the resolution of my project. So I'm going to change here this resolution to this, so that time, if I put a transform node, or if I put another reformat node, or if I put another roto shape node, everything will always have that resolution. You see, the roto actually has 2560 by 1382, and the reformat as well, so that everything is kind of matching. So now that that's merged, that's my pre-comp here. And this is why I was showing you how powerful compositing and node compositing is. Now, notice how this is actually a tree, and when you press the command or control button, you get these little dots. That allows you to organize this a bit better. I like to organize my scripts so that they are a bit more tidy and a bit more organized, so that you can kind of continue working. Obviously, if you press the dot button, You also have a dot as well if you want to. You can have more dots. That's just like organization point of view. But the reason why I was doing this was because I wanted to show you the power of node scripts, you know, how you can actually do so many different changes, do so many different changes in the fly and actually tweak things on the fly as well. So let's say that, for example, I'm sitting with a director and I want to experiment a bit. So let's say that I'm now select this and I copy paste it. And okay, so I now have two comps. And because Nuke works in a way that it's reading the file from disk. So Nuke is reading the file from disk, which means the file is not actually cached physically. It's actually not being converted to some weird format like a Flame would do or like Avid would do. So it doesn't really matter how many versions of the same image you have because it's always reading the same file. If you look at the read file is pointing to the same exact position. So this is actually the path in the computer of this sequence, okay? So the powerful thing about this is that now I can do multiple versions and show my client. So let's say that the client would say, okay, I need this guy to be blurry. Okay, that's fine. Obviously, I'm not saying I would just use a defocus node. I would probably use a Z defocus node. But if I just want to like experiment something really quick, I can just put a defocus node here. A defocus node is part of the blur tab, which is the filtering tab, where you have all the nodes that have to do with filtering and blurring. And so in this sense, if you go in here and you put the defocus node, you see that I can defocus the image, okay? So now let's say that I defocus a lot. Like let's say that we defocus maybe 10. That's the defocus amount that I have. Okay. And so that's version number 1. Let's say that then my client wants to also have a new version. So I'm going to go back to this script here and I'm going to copy paste because all the nodes can be copy pasted, right? So I can copy paste this defocus node, select the monster, paste it here, and now I have another defocus node. And let's say that now this one is on 20, for example. So, okay, so now my client is, okay, this is version 20, and remember the viewer is set to 1 on my viewer here from this merge node. I can select this merge node and press 2, and now I have both of them. So now I can like put this in full screen and show my client, okay, this is with 10, this is with 20. And in fact, I can even play it back, and while I'm playing back, I can swap around between them. And remember, I have full frame processing here. And once it's cached, once both of them are cached, because I have to wait for them to both cache. So now I'm going to cache the second one. So you see it can cache both of them at the same time, which is really cool. And in fact, if you wait a little bit now, this is going to take a bit of time because obviously it's caching both of them. So now I have 1 and 2. So now I can actually jump by pressing, you see here, pressing 1, 2, and 1, 2, and I can view it at the same time and play it back at the same time. And this is really powerful when you're like debating this with clients, you know. And this is why Nuke Compositing is so powerful, because you can kind of like copy paste stuff all the time. I'll give you another example. Like imagine that you put a grade node here, and obviously we're gonna go through premultiplication in a second, because there's of course rules of premultiplication that we need to keep in mind to do something like this. But if I put a grade node here, and let's say that, for example, the client wants the monster to be a bit brighter, you know, like let's say that he wants for some weird reason, he wants the monster to be a bit brighter, or he wants the monster to have like a little color into it. You know, let's say that they want the monster to be a bit warmer. So, or maybe a bit colder. Let's say they want the monster to be a bit cooler. I'll talk about color correction in a second, but you see, so now that's the version with the cooler, and the cool thing about this is that because it's nodes, I can still view my original. I can still then, you know, by just pressing 1. That's why Nuke Compositing is quite powerful. Because you see, I'm now viewing this monster because I've pressed 1 into my viewer, right? You can kind of see it graphically here. But then if I press the defocus, if I select the defocus and press 1, now I'm watching just the defocus. And if I press 1 on the grade, I'm now just watching the grade. And you can even play it back. So I'm now just watching the monster. I'm now just watching the defocus. And I'm now just watching the grade node. And you can't really do this very easily, this quickly in a layer-based compositor, because on layer-based, you have to like switch off a layer and switch on a layer, switch off a layer. And you can't really quickly view things like this unless you have buffers, you know. I think that's the thing. So And the same way that you can even see the result. And the cool thing about this is that you can also like switch things really quickly on the fly. So if you're working with a client next to you, or even if you're the experimenting thing, because I do think that Nuke becomes a very experimental application because of this. And think about this, like Nuke, you know, anything I'm teaching here can be still used on Fusion, because Fusion is also a node-based compositor. So you can also use it in Shake, although Shake doesn't exist anymore. But these things are not just for Nuke. You can do these kind of things in Fusion as well, which is free. Okay, so let's go back to this. And before we stop the break, the other thing also that is really powerful with this, not only you can view just one layer, just another layer, but also by pressing the D button, which is the button for disable. If you select something, you can disable a node really quickly. In fact, you can disable 2 nodes at the same time. You can disable just one node. You can disable just the other node. And this becomes incredibly powerful when you're working really quickly. And I think that's why so many people love node compositing. So let's carry on here. Let's do another example here. So on this one here, let's imagine the client wants it to be a bit warmer instead. And let's say the client, for some weird reason, asked me to scale the monster a little bit more. You know, let's just like pretend that. So you see how quickly I've now done 2 versions, and I have both of them side by side here. So the next time client comes in, I can just show them right away the difference between the 2 of them by just doing AB, AB, AB. And I can also like disable one of them, disable the other as well. So I can actually use the disable button to my advantage and really kind of like go quite fast in terms of compositing and be quite creative. I think that's why I love node-based compositing, and to a point that now, I'll be honest, I hardly use Photoshop these days, especially if I'm just comping layers. Like, I just use Nuke instead. It's just much easier than using Photoshop. This is one of the advantages of really having node compositing, because, and again, like I said, like, it is possible for you to do exactly what I'm doing here in Fusion, okay? Just keep that in mind. As I was debating, it's really cool because you can kind of like start doing multiple versions. You can kind of like do versions where you disable something and enable something, grade something. But obviously this is just scratching the surface, right? So this is really scratching the surface, because Nuke has so much more to offer. So having said that, I'm gonna change a bit the conversation just for a little while here, and talk a little bit about why also Nuke is so, you know, used in the industry for CG compositing. And the reason for that is because of the way that it handles channels, okay? So for that, I'm going to open up a script here so that we can kind of go through that real quick here. So I'm just gonna open up a new script. And gonna go into this fella here. So I'm just gonna kind of like, let's see here. Yeah, so I'm gonna just like do this one here. So let me just give me a second. Yeah, so so this is the same. So this is the same project. You know, the same project that we were doing on the other shot, but this time this is another shot, of course. So this is like this shot here. Obviously this is not comped. This monster should have been behind these guys, so you need to roto these people so that they are in front. So that's the other thing as well. So I'm gonna just like set up the range here so I can show you what I mean when I'm talking about multipass compositing. So I'm just gonna like change the range here and change it to the same range as the other shot. So also I'm setting it to 24 frames per second so that we can kind of like use it. So obviously this comp is much more complex because you would have had to rotoscope the people to be in front. You would have had to like address the depth of field. You would have had to like address a lot of the things. So I'm going to talk just a little bit about channels and how that operates inside of Nuke, because that is really pivotal in the way that you composite CG compositing. I love that my students, because they knew that this guy was going to be in front rotoscope, because the monster should be behind these people. Notice how the animation just goes. It's so funny. Look at that. The animation just kind of goes like that. It's so funny. But that's just because, like I said, like we knew that he was going to be comped behind these people, not in front. So this monster here, which is supposed to be comped behind, this is a bit of a different render from the last one we saw. This is again a V-Ray render still. But one of the advantages that Nuke has to other types of softwares is the way that it operates with channels. And again, don't forget that I keep saying this, but it is, I'm skipping a lot of things. Okay, so you guys are not going to really be fully working with Nuke after you watch this stream. It's like you need to kind of like watch other things and do other courses. But the way that this works is that you have access to a lot of layers, because when you render something in the CG package that has multipass EXRs or multipass AOVs, you then tend to have something like this. Like, remember, we always have our GBA here, which is like the red channel, the blue channel, the green channel, and then the alpha channel, as we discussed before. But Nuke has the capability of bringing extra layers in the same EXR. In this situation, for example, here we have the global illumination. I'm gonna just gonna brighten that up a little bit so you can see it a bit better. So this is the global illumination, which is nothing more than the bounce light of the environment. We have the subsurface scattering, which is basically the semi-transparency of the skin. We then have the fire shot, so this is like from the front fire light. Then we have the diffuse itself, which is just the color with no shadows, with no reflections, with no with nothing extra, and no lights as well. So this is what we call the raw diffuse. Then, of course, we have the light from the left. We then have the front fireplace light as well. We have then the full light as well. Then we have the fire back, left back. We have then the fire front left. Then we have the warm light. So all of these that I'm showing you, these are basically like light passes and AOVs that you usually render from a CG package. You know, so from a CG package, you render all these AOVs, and then you bring them into Nuke to composite them. And they are very helpful because they allow you to control little things like addressing more light to the left or more light to the right. And they allow you to do small tweaks without having to re-render everything again, you know? Like, so that's kind of the whole point of this, is for you to not have to like go back to 3D all the time. And obviously I know that these days, like, with the advent of real-time engines and the advent of, you know, of Redshift, everything is getting faster and faster and faster, but we still need to output these things because it's still faster to tweak a light in comp than it is to go to 3D, tweak the light, and then render everything again. At this moment, it's still faster. Obviously, that will change. Like, there will be a moment where real-time engines will be faster and Redshift will be faster, and perhaps you'll be able to render quicker, so that means that you don't need to bring all these layers like that. That's kind of what Unreal is trying to do. Unreal is trying to make it so that you don't have to care about these AOVs. But remember, though, that we're always chasing our tails, right? So yes, right now, if you're working in HD, you can use Unreal. It's all in real time. But 4K is a bit of a stretch. And then let's start talking about 8K, and then we go back to offline rendering, because as the resolution grows, the render engines don't have enough power, and so we tend to go always back to brute force rendering. That happened when we switched from SD to HD, 720 to HD, and then from HD to 4K, and now it will do again when we switch from 4K to 8K. So I think offline rendering, compositing, and the way that you work with AOVs and everything will not really change much, because resolutions just keep going with IMAX, and you'll just need multipass EXRs, you know. So yes, Georgie, to answer your question, these AOVs are nested as one EXR. Yes, they're not separated. So in Nuke, you can work in both ways. You can have an EXR that has everything nested, like you said, or you can just work with everything separated, where you have layer by layer by layer rendered out, you know. Oh, look at that, Nuke crashed. I was wondering when we were going to have a crash in Nuke, and I guess we just got one, so I need to open Nuke again. Well, that was nice. Look at that, Nuke crashing like that. So this is why I save all the time, because Nuke does crash quite a lot. I don't even know why it crashed. There's no real reason for it to crash. I'm not even using, like, basically OBS is using about 10% of my CPU. So it's not like that would have been the reason, but I don't know, like, that's why you save. Just open this up. Where was I? I was on this one, I think. Yes, autosave. By the way, Nuke's autosaves, if you don't change the mouse, it autosaves every 5 seconds, I believe. Something like that, so nothing to worry about there. And basically, we were not even doing anything. We were just like, oh, actually, wait a minute, this is not the script, is it? No, this is the script. Yes, it is. So it doesn't really matter. As I was saying, so yeah, like we were having like a big discussion about like because people ask me all the time, oh, what about Redshift? Is it going to change things? Is it going to make it different? Well, not really. Like Unreal and Redshift are really cool, and especially Unreal is really cool, but Unreal still can't really make a proper 32-bit float or 16-bit float render with high quality dynamic range, and you can still, it's still a bit of a hoop to do ACES rendering. Obviously, this might change in the future, so if you're listening to this in the future, never mind what I've said. But at the moment, it's even rich people's Nuke crash. Of course, like it doesn't matter which machine you're using. It doesn't matter how powerful the machine is. Nuke crashes all the time. It does, but that's normal. Like every application crash, and the only thing you do is you open it up again. I don't care about a machine crashing. I don't really care about Nuke crashing. I feel like when you're dealing with something that is so high-end, it's like a Formula 1 car. Think about it. Like I always give people this comparison. You know, if you look at a Formula 1 is the fastest car in the world, right? But it's so fragile, you know, like so anything can break it and then it just stops working. So I feel like it's kind of the same thing, you know, like I feel like Nuke is a bit like that. It's like a Formula 1 car. It's so advanced and it's pushing the pixels so much in 2D that it kind of drops out. Okay, so these would be all the passes, and you also have reflections. I also have refractions, which in this case it doesn't really exist because there's no refraction because he's like skin. He's now no glass. Self-illumination. There's no self-illumination. There's some shadows as well, and then some specular, and that's it really. So these are all the passes I have. I also have like some other passes, like in this situation, we also have like passes like you know, well, we'll go through them in a minute. We have also like depth passes, and what I'm showing you here, these are what we call beauty passes, which are the passes that will allow you to do the render itself. So, but the way that Nuke operates is really peculiar because you see, when I'm merging something here, like when I'm merging this monster, and obviously I know that this is not matching, you see, like we need to like work on the blur and the defocus. None of these things are matching, but that's not the point. I'm just teaching you Nuke. I'm not really like going through it in detail right now on this shot. So the way that this works is that the channels are always there, right? Like, so the channels are always there. We always have access to the channels. But when I do something to an image inside of Nuke, like imagine that I do a grade node here, and you see on every node in Nuke, whenever you're operating on some level, like even if you're doing a grade node, notice how if I make it brighter, or if I change the gamma, for example, like if I change am I affecting that image, you see it says here channel RGB. That means I'm affecting the RGB. So let's say for a moment, just to the sake of it, let's say that we multiply this by 10. So we have a super overexposed monster here. Notice how the RGB, which is the main layer of my Multipass EXR, is overexposed. But if I go into, for example, the subscattering, notice how it's not overexposed. The reason for that is because an EXR, an EXR does not, has the multipass. It has all the layers, but those layers are not being affected by the mainstream. Think of it like, imagine you have several pipes of plumbing, and we're only affecting the plumbing, one of the pipes. We're only affecting the pipe that has the RGB. We're not affecting the pipe that has the subscattering. Obviously, I can change that. I can do the grade node and I can tell the grade node, okay, you should affect everything. That's fine. And now it's affecting all my channels, including the GI, including the diffuse, including the beauty, including everything. Or I can just tell them to just affect one specific channel. But here's the kicker here, and that's why this becomes confusing. Just notice here, for example, when I'm looking here, I'm looking at this read node. And then I look at the grade node that affects the subsurface scattering. When I look at that grade node, notice how the subsurface scattering did not get brighter. It did not get better. It did not become better. The reason for that is because this grade node is literally just affecting that pass. It's just affecting that pipe. And it does not contribute to the general pipe that exists inside of Nuke. So it's not contributing the beauty. The reason for that is because for you to be able to change things on the fly, you actually have to do what we call in the industry rebuilding the beauty. Basically, compositing all the AOVs together to have the result that we already had. Okay? So, yeah. Now, one thing I must say, because people are debating ACEs and ASOE in the chat, don't forget that I am not running ACEs because this is an old render, and I'm actually in fact running an sRGB LUT on my viewer because I'm just broadcasting on YouTube. Normally I work in Rexon 09, but we're not doing that because I'm actually working for the stream. You know, I'm streaming on YouTube, and streaming on YouTube is much better to stream in sRGB because that's what most people watch in their computers. They watch in sRGB. So that's why I'm doing that. So now to show you this, I think I need to open a script. I prepared the script already just to kind of show you this. I have a question on the chat here, which is really loaded. What's the difference between sRGB and Rexon 09? Well, the difference is not much, tell you that. sRGB and Rexon 09 are almost the same, but the difference is because Rexon 09 is the curve, the LUT, that is for delivery for TV and commercials and broadcast. And sRGB is if you want to deliver for the web. That's because most monitors are set to sRGB when you're viewing a desktop, but a TV is set to Rexon 09. So they have slightly different gamma levels and slightly different color variants. They're very similar, very, very similar, to a fact that if you put them side by side, they look exactly the same. Like, oh yeah, maybe this will be enough to show here. So now it's a bit messy here, but sRGB is the blue one and Rexon 09 is the pink one. And notice, like, this is the spectrum of light, the visible light, okay? And so sRGB only can see the light inside this pyramid here. So any value outside this pyramid is not possible to be viewed by sRGB because sRGB is really limited. It's not really good in terms of color space. And so that means that, for example, this type of green is not possible. But notice how pink is Rexon 09 and blue is sRGB. Notice how it's almost the same. So Rexon 09 has just a little bit more darks, has just a little bit less blues. And so it's just like a little offset by sRGB, but it's almost the same. But compared to, for example, DCP, which is DCP is like what we see on the cinema, which is the blue one, which has a huge range of color. Really going off topic now. This is like much more advanced than what we are going through here. I'll explain this by hand, don't worry. But just like I said here, you see, this is another render that also is similar to the one I was showing you. Like, this is actually from a project I did years ago for a game. And again, we also have the same stuff. You know, we have the diffuses and we have the speculars and we have all the control we would have, the subsurface scattering. We still have all the control of those passes. And now, the concept of using CG compositing in Nuke would be very similar to this way, where you would comp and merge all these passes so that you rebuild the beauty, okay? So I'll give an example. I'm going to put the viewer, where's the viewer? The viewer is like really far away, all the way up here. I'm going to start by showing you a more simple render that is a bit more simplified, okay? So let's talk about this one. This is Redshift, by the way, that what I'm going to show you. So this is Redshift. So this is a Redshift render. And I'm going to just like put on input here. And so you can kind of see that this is the raw 3D that we got from Redshift. So it's not treated. There's no like depth of field. It's really the materials. It's just like the raw stuff. But you see that we don't like all the AOVs are here merged together, and obviously these ones are not. They are separate EXRs. But just to show you the point, like in here we have like just the diffuse, and then we have just the GI, and then we have just the reflection, and then we have just the specular, then we have just the refraction, and then we have just the subsurface scattering, and all those kind of things. And the cool thing about this is that then if you merge them all together in a certain way, you basically get a match. So for example, now my viewer, I'm viewing this versus that, and as you can see, it matches perfectly. So this is what we call in the industry a rebuild. We're rebuilding all these AOVs and shuffling them out. And so if I go back to the statue here, it would be the same thing as well. If I now look at the statue and I look at the result of the statue, you see, notice how I have a match as well. So if I look at A, B, I have a complete match. Now you're probably thinking like, but Hugo, what's the freaking point, right? What's the freaking point if you doing all this crap just to have the same image? Well, remember when I was showing you the fact that if I go in here, and I have like, imagine that I have the subsurface scattering. Remember when I said, okay, let's put a grade node here, and I want to change the subsurface scattering. So I'm gonna, in the grade node, change the channel to just support the subsurface scattering, and then I'm gonna multiply up the subsurface scattering. And notice how nothing happens on the image, but if I go to the subsurface scattering pass, it's actually brighter now. You see? Now, the way Nuke works is that when you're doing this, you're compositing on a different channel. So that's why Nuke is so powerful, because you can kind of like comp in different channels. You can comp on just one channel, on just the other channel. And so a lot of times we do a rebuild because we want to tweak something. So what's the point of this? Well, I'll show you what you can do with something like this. So for example, here's the subsurface scattering alone. And now if I put a merge node here on the subsurface scattering, just on the subsurface scattering, for example, and now I look at this subsurface scattering and I'm thinking, okay, I want the subsurface scattering maybe to be a bit stronger. So I'm going to mid-tone it a bit. So I'm going to basically just like increase the mid-tones of it and maybe make it slightly brighter. You see, on this grade node, I'm basically bringing the subsurface scattering up. And so now if I look at the result of this, so let's say that we look at the original, that's the original, and now I put my viewer on the result of that comp. So notice now how my subsurface scattering is brighter because I've tweaked it, but notice how the reflections are not, and nothing else is. And to a fact that I actually, now because I have separated everything, I can actually like tweak things to a really granular level. So let's say that on the subsurface scattering, I open that up, and let's say that we want to remove the subsurface scattering. So now there is no subsurface scattering. So notice how I'm actually now tweaking at a shader level. So now I've removed the subsurface scattering completely, or I increased the subsurface scattering. And now this is, look at this, for example. That's, well, I'm going to go to the first frame here. Look at this part here. So if I remove it, and now it gets semi-transparent because I'm applying the subsurface scattering in and out. It's like a system. It becomes like a pipeline, It's kind of like that, really. The same goes for, like, for example, lights. Like, imagine that, if I look at my, let's see here, my reflections, for example. So if I put a grade node here and I decide to remove my reflections, for example. So if I put a grade node here and I now remove all my reflections, well, actually, I think these are all from the specular, probably. So, sorry, I should have done that there. So, if I go to my speculars here and I look at the result, so if I now go into the original and the new one, notice how I now have the way to actually remove reflections. So you see, I'm tweaking, because I've made a system where I'm basically having layer by layer by layer. It's very easy for me to just basically remove completely one reflection or put back the reflection. You see what I mean? And in fact, I can even bring the reflection up. So This is why it becomes so pivotal for you to, in film, use multipass EXR so that you can actually tweak just a reflection or just a light or the scattering or just a certain element or a certain part of the script, you know. And I guess you've seen this before on my streams and on my YouTube channel, and I do have a few videos like this, but I just wanted to kind of go through it to the basics. And what I'm going to do now after the break is I'm going to comp and shuffle one of these Multipass EXRs by hand so that you can kind of see how it works, okay? Yeah, so the reason for Red Stallion is asking me why is it still sRGB? That's because I'm doing something which I call a shuffle, and we're going to go through this in a minute. But you see, a shuffle is a way for you to shuffle a specific layer into the RGB level. So I'm basically moving that layer from one channel into the other channel. That's what I'm doing here. And that's what I want to do by hand. You know, that's why I wanted to do it like manually so that you can see it. And that's what we're going to do next. Okay. But in the meantime, we're going to do another break. You know, whoever came up with Multipass EXR really did the directors a favor. Yes, they did. Maybe they were a director. Maybe they were directors.